Okay. Hey, good morning, everyone. So, whoever joined new, right? Okay. So, I'll just give a brief. What is it we are trying to discuss? Okay. So, we are right now. We are discussing into two topics. So, one is into Git and another is into the containerization. So, Git we left with we were going in a four parts, and this is the last part where we would like to get a look at the history. Like we'd like to make a changes or correct our changes. So that part was pending. That would be a little session. And after that, I'll try to give a introduction to containers, not Docker exactly, but just an introduction to containers. Maybe in the next session, we can, like hopefully by tomorrow, we can cover the Docker in depth. Okay. So yeah, I hope people are familiar who are coming here, right? People are familiar with the Git, I assume. Yeah, if not, just a small intro. So yeah, like Git is a source code control version. Like basically, we can store our code and we can work on the projects, or we can share or collaborate on the code. Okay, this is how a typical Git looks like. Yeah, so this is how we are keeping on making changes, and we can reuse the existing, we can reuse the context or something like if we want to reverse the whatever the change we did earlier, so we can do it back. Okay, so if we go here, yeah, so we were doing changes continuously. Like, so what we do, our strategy is, so we have our local branch. Okay, so we'll make the changes here. Yeah, we have our local branch, but we have our main branch. Okay, the main branch is here. Okay, so this would be here. Okay, so let's assume we are making one more change. So that change will go and sit here, right? So as a new commit. Okay. So here, when you're trying to make changes in your laptop locally, so what will you do? You will go clear test it. Okay. You will go check it again. You will do a correction. So each change will be looking like a one commit history. So total, you have like nine commits. Okay. But nine commits, go and change here, save it as a one commit. Okay. So that is called squashing. So what you mean by squashing? Yeah, basically act of compressing or a paper TR idea. Okay. So basically what you're doing, so this is all your rough changes. Okay. So you'd want to make something. Okay. And then you are changing it again and again. So final version is this one. Okay. So when you have, this is the final version. Okay. So what do you do? Once you are this, so you will make a merge request to main branch. Okay. So all these nine commits will go as a single commit here. Okay. So if you take one example, go to pull request, closed one. Yeah. So if you see this changes, right? One, two, three, four, five. So I'm trying to do the changes continuously and all. Okay. So, but all these changes, they went into alpha as a single commit. Okay. So that request, that looks like this. So it went from where to where. So production from alpha. So I'll go here. Yeah. So all the changes, whatever they did, so we have a single commit. So this is called git squashing. So whenever you are creating a pull request from what is it, from dev to or from your dummy branch to this one, right? So you'll get an option squashing your previous commit. Okay, so let me show you that. So this is dev. Okay, so we are in full version now. So what will I do? Git checkout, uh, patch 3. Okay, so we created a new dummy branch from dev, and then we are making some changes. Okay, so what changes we can do? Maybe we'll make this site context or something. Okay, so plant-based alternatives will be. So git add. Okay, so if you see this one closely, okay, so what do you see here? So it says to add a file, you need to do a git add. Okay, let's assume I did multiple changes. Okay, so instead of this, so I read a readme also. Okay, readme. So So I make two changes. So now if you see git status, so I have two changes. One is this and this. So I'll add both. So like this, there are 10 files staged to commit. Okay. What I want, like I would like only, let's say I change my decision. I just want only HTML file to change. Okay. So this is where you have called git restore. Okay. So add. So I'll make this commit. Hmm, Update YAML the data. Okay. Now what will I do? One more commit. Okay. So git status. My bad. I didn't remove this one. Okay. What change? Okay. Now if I do git status again, so I have two files, both, and then I have an option like I'll remove only particular file. Okay. I just want only readme data to update. Okay. So I want to remove this one out. Uh, okay. So git restore status. No, didn't work actually. Git restore staged. Okay. So if you see here, right, how the things looks like. Okay. So you have some files at your local place. Okay. Local. And then you have something called staging area. Okay. So how does the staging area looks like? This is the one. Okay. Okay. And this is what it says. So gets not changed for commit. Okay. So how does the staging it goes? So you'll do a git add. Okay. And then changes will be ready for commit. Okay. Yeah. So I'll ready to commit only this file. Then I'll try git rm also. Yeah, let me try this up to so far. So git push, it will create a new branch. So if you see here, right? Okay, see all these changes are happening in my laptop. Okay, so this is my laptop. Yeah, all these changes are happening in my laptop, but this is my origin. Okay, origin as in remote origin. So that is not GitHub here in this place. So what it says, so far whatever you made, so branch once you made a commit, right? So so yeah, one second. So as I told, the changes are in my local laptop. Now I have my remote. So whenever I'm creating Git branch locally, it will create locally. This branch is local. Okay. So your remote doesn't have an idea. Okay. Your .com doesn't have an idea. Hey, there is a new branch and all. So what I'm supposed to do? So for this, I need to do something called Git push. Okay. So when I'm doing a Git push, it will give you an option, Git push setup stream. Okay. Yeah, so that's about it. So once we do that, so our branch will be in the remote. Okay. So we can see, yeah, it also giving a provision to create a pull request. So we'll do both. Yeah, you see, there is a patch 3 branch got pushed recently. Okay. So where we can see all the branches. So this one. Yeah. So this is where we have the patch 3 branch. Okay. So now we have the pull request. So pull request as in you're merging your changes to one branch to another one. Okay. Yeah. And let me do a pull create. Yeah, so this setting was not visible to me. So let me go to settings and general pull request. Yeah, so this one, this squash merging, right? This one was already there. Allow under squash merging, commit this commit message presented to. Yeah, so this is what I told, squash merging. So for some, let's say if it is a GitLab or something, you will have this option visible. GitHub, it's maintaining at this one in the settings option and all. So whatever changes I'm making, so all these things will be a squash merge. So this commit one, commit two, everything will go as a one single commit. Okay. We'll take a small break here. So any questions here so far? Yeah, like maybe some people join new. So any questions here? Mm, yeah, I hope I'm audible.
Yeah, you're audible, Datu.
Any questions, Shashi?
Mm,
Yeah, even basic questions are also fine. No problem. Yeah, is it okay? Shall I proceed forward? Is that okay?
yeah, go ahead.
Yeah. So yeah, like right now, all this is change management. So I mean, all this is like source code management. So we are trying to update the code, or we are trying to come back and all how this works. So view pull request and merge. Okay. So now if you see here, there is a cleanup. Your branch 3 can safely delete it. Okay. So now what happens when you do, you create your branches like this. So you'll have multiple branches created. So you have your main branch. Okay. And then you'll have your dummy branches. You'll create for staging the changes and all. Okay. So the pull request offers an option to clean this, delete this branch. So there is a setting someplace where you can automatically delete the branch once the change is done. Okay. So the branch will be deleted in remote, but not in local. So unless you go and do a git pull, right, the branch will still be there. Okay. That meaning is this. Okay. So to merge with patch 3, but there is no such reference patch was did. Okay. We check out dev. Okay. So this is one. So when I'm switching to another branch, so there is some files, okay, written by that means what? Like I didn't do a commit. Okay. So yeah, so what it says is, see, you have some changes here. Okay. Okay, you have some changes here in the staging area. Okay. But you didn't made it to commit. So once you make a commit, everything will be formed as a one branch. So this all will be one pack. Okay. But you commit who are switching to another branch. Okay. Now, when you are trying to switch to another branch, right? So what happens? All these files, whatever you do, they'll lost. Yeah, all these changes, whatever you do, you might get lost in the staging. So for that one, let's say we do want to visit it later. Okay, all these files, we do want to visit it later. Maybe like future tomorrow, I want to relook at this one. So what I can do a stash. So you can commit your changes or stash them. Stash means like what? Like we are just getting rid of it for a moment. So I'll do git stash. Yeah. So if you see here, right, the working progress index state, it's saved into this one. Okay. So this ID I can take, and in future, if you want, I can just go and take this. So git check out. Yeah, your head is in detached state. You make experimental changes. So what happened? We are in this particular point. Okay, it's not a branch. It's just a detached state. Like it's a scratching place, or it's a staging place where we can see our changes. Okay. Let me go back to dev. Okay, git pull. So what do we want to do next is we do want to roll back our changes. Okay. Let's say we made one change. Okay. So let's take this. So we made one change. Okay, change 1, 2, 3, 4, 5. So we do want to undo our last changes. Okay. So either in production or in dev, like let's say you made one change. Okay. So that broke the things. So this particular change, it broke your things. Okay. You want to revert it back to this older version. So this is earlier change. Okay. Let's say 1.1 and this is earlier change 1.2. Okay. You do want to once when you did into production, this 1.2 got broke your production change. You want to the changes quickly. Okay. So for that we have multiple options. So one is like the particular one is like git revert. Okay. So we'll do it from UI. That's one thing, or we can do from command line. So we'll go to this one. So yes. Yeah. So what is looking for? We're looking for git revert and git revert. So what it says, go to history. Okay, this is a command line tool. Okay. Yeah. So it's their own tool. So we do want to look it from our terminal there. Okay. So git checkout dev. And so we'll do git log. So when we do a git log, so we will see all the latest changes, what timing we did. Okay, so 11 to like that's Sunday. So Saturday, this is today's. Okay, so what are all the changes we did? So we'll see it in here. And where is our head? Head is nothing but a pointer. Okay, yeah, head is nothing but a pointer where, let's say, where you're working currently, whether you're working in this one or you're working in this particular one, or you're working in different branches, this branch, this branch, this branch. So your head specifies where is your terminal in. Okay. So now, if I read their this thing, right? So what will I do? So I'll do git revert, one last change. Let me look at my website. How does it look like? Okay. So, yeah. So me website, like in the last session, I kind of showed how I deployed this website. Okay. If you see here, we have this one, our site available at our site and all. So this is the change. Right? So now let's go to git revert. So in the revert, so I'm supposed to give a commit ID, I guess. Yeah. So what will I do? I'll take my commit ID. Okay. So git log and this particular commit ID, which is this. So this is a short commit ID. There is a long commit ID. Okay. So if you go here, go to dev. Okay. And if you see here, so this is a short commit ID, 2E. Okay. And this is a long commit ID. So either both of that works. Okay, so git revert. Okay, commit is a merge, no option given. Okay, so so if you see here, mainline parent. Okay, so it's a commit, so not able to get the proper git commands. Replace that you will never want these three changes body. So okay, so what this documentation says is, so we cannot work with the git merge commit directly. Okay, so what we are supposed to do, we'll take a one more branch, which there is no merge commit. Okay, so we'll take our fresh branch. Check code. Okay, so there is a patch for a new branch, and there is one change here. Now, yeah, this is the commit ID, and I made a change. So what will I do? I'll take this one and try to do a rollback. Okay. So see, you have this one as a parent, and you have this one as a commit. Okay. So wherever our pull request, I think since we deleted the branch, there is no parent. Okay. So let's pull request. Let's do a pull request. Yeah, let's see if we have a parent here. Okay. So yeah, there is two parents. Okay. So now I'll try git more git revert on this. Okay. So git checkout dev and git log. Okay. And now yeah, this is 11 git pull. Yeah, 11:14. So this is the one. So I'll take the commit ID either from long from or the short form. Okay. So the commit ID is this. So go here and git revert. So -m, let's give a parent. So I'll give this one as a parent. Patch 3 and 23 change. So I'll give this one as a parent. Okay, not the right name. Sorry. Yeah, let me try on this one again one more time. So git revert 7. Okay. So what I'm trying to revert the change for this patch file, whatever the change is there. So the change trying to revert. Okay. So I can add a commit message here. So I'm doing Q exit. Okay. So the revert is done. So now you go ahead and see how it is. Okay. So let's push the change. Okay. Now go ahead and see how the revert message looks. Yeah. This is the revert. So if I see here, at first we are trying to change from, we are trying to add 23. Yeah. Now we remove the 20. So that is what revert is. So basically, either we are pointing that last one to this one. So earlier it was here. Okay. Now the head will be, our branch will be up to state of this one, 1.1. So earlier version and all. So that's what revert is. Okay. Let's say you want to take your branch to a particular commit. Okay. So you have one commit here, you have one commit, you have this one. So you want to take your branch to this particular commit. Okay. You do want to work on it, or sometimes you do want to take it there. So that is, for that we have something called git reset. Okay. And you have two options there. So one is git reset soft, and another is git reset hard. So all these are options to correct our changes. Okay, let's say we went in production. Somewhere we identified that some issue is there. We need to roll back. Okay, or sometimes we need to work on very older branch, like 100 commits are there. You do want to work on 40th commit or something. Okay, so at that time you can take a commit and do a checkout. Okay, let's say, so you can take this one. Okay, and git checkout. So git switch, sorry. You are in detached head state. Okay. So what that mean is, yeah, see, it says this file is not there, this file is not there. Okay. If you do lsltr, ls. Okay. So there are only 3 files. So what happened? It took our head point to this particular very older version. Okay. And it is just exploring purpose. We are not saving any changes. So if we want, what you can do, git switch -c new branch. Okay. So what I'll do, git switch -c old patch. Yeah. Now all our changes, whatever we want, they are in the old batch. Okay, old, a very old patch version. Okay, but we want our changes to be in git checkout. Okay, so whenever we do, so we can visit our old branch. So that looks like this, and to see the changes, right? Okay, let's see. Yeah, I'll see if that old branch comes in. Yeah, no, maybe you need to push as a new one. Okay. So another thing, yeah, we are discussing about the reset, right? So for that we need a commit ID. Okay. So we are in git branch dev, and let's go for the git log. Yeah, let's go for git log. So we will take this one. Okay. Or let's go for, yeah, September 7th. So I'll take this commit ID. Okay. So git reset. Uh, let's see the command. I think this is what changes the things. So earlier one, my bad. So earlier one, the git revert, right? It will take you the wherever branch you want. So git reset hard, basically it reverts the changes either in a soft way or hard way. Okay. So let's see. But yeah, git reset hard. So yeah, this is the one that will take you commit, whereas git revert, right? It will take you wherever commit you want. Okay. So what we'll do, I'll just go ahead and give this, which is okay. So do see the hmm, I don't know which branch it did. Yeah, dev, but it didn't work properly. Yeah, let me test on my patch branch. Okay, let's check out. Status. I'll add file. Okay, the file members. Okay, we add with the updated Python file. Yeah, so now I want to revert this change. So git resolve. It's not working as expected. Allows you to warn directly branches. So the soft moves head mostly with the head from Git. It doesn't create a new commit and actually move to head to any commit. Okay.
So
So
what is
class.
the error you are getting?
No, I'm not getting error. So I don't see the change. So where it is going. So let me try for a different commit area. Okay.
Command? What is the command you are using?
Git head reset actually.
Git reset.
Let's go for patch 5 branch. Okay. So I'll go to take this one. Git reset soft and yeah, 717 double A triple nine. Okay. So 717 double A triple nine. Let me confirm. Double A 39. Because okay. So this is what my bad. So this is what. So taking a git reset, right? So it branch to this particular state. Okay. So earlier, whenever we are making change, so the revert works in a different way. But git reset basically it took all your changes into this particular version. Like so 1, 2, 3, 4, 5. So it ultimately took your change to here. Okay. But it kept your files. Okay. So we can see readme demo.py, whatever the files that were changed or newly added, right? So that were there. Okay. So I'll do commit. I don't think, yeah, commit for reset stack. and git push. Okay, git and git push. Yeah, so we will see where the file goes. Okay? And here we can see what and all files got changed. No, it didn't made any changes then. Okay, let me try git hard then. Okay? Head is now at 20. Okay, so git status. Yeah, let me read another version. Okay, so let's see different date.
Why it is failing? Is it because of permission issues or how?
No, I am not making the changes clean. Okay, so let's see.
You have to see before committing, you have to add, right? Add all the files, then commit, then push.
Right, let me see that.
Git add star, then git commit, then git push.
Okay, so the reset didn't made any problems. Okay, only the hard soft reset didn't cause any problem. Okay, yeah, that add thing I did, man. Okay, so add part I did.
Hmm.
The git reset soft didn't make any problems to us. So git reset hard, what it did, it changed all the files. Okay, so let's go back to very old version. Okay, so I'll take dev. Yeah, I'll go to this particular one. So git checkout dev. Yeah, the question is, will the new changes comes or not? No. Okay. So git log. So I copied a commit ID there. So git reset hard. Okay. So I think all the things went in. I don't have any option to, what is it, recover the files. Okay. If it is a soft version, I have to recover the files here. So if it is a soft hard version, there is no way to recover. Okay. So this itself is a commit, the git hard reset, right? It itself is a commit. So there is no way I can change the things. Okay. So git checkout -b reset dev version 1. What? Oh, it break the thing service. Yeah, it did break the things already. So here's my Docker file. Yeah, somewhere up to here, what are the changes we did? So we lost the Docker file. Okay. Let's go back to our patch file, what exactly we did. Or we said dev step. Yeah, I think it's better I'll do one more experimentation and come back. So basically, we are playing with the history here. Like we want to go back to one particular change and all. So let me go back and like I'll revisit the things. Okay. So somewhere here we need to be little careful because we might lose our changes. So whatever the changes we did here, right? So at some places, if we are doing a reset, so usually it won't happen. The reset will not happen on the production branches. But in case if we are doing reset, right? So we need to be a bit careful while doing it. So yeah, I think we are running out of time. So that's about the Git. I think we discussed about the Git conflicts, merge conflicts. So it's like, okay, when two persons are trying to make a change, right? So that's where the merge conflict comes. That is one thing. And I think I can conclude here. That's about it. And about the container, right? Okay, I'll just give a brief introduction. Maybe tomorrow I can take a full session then. Okay. So we have our Linux VM here. Okay. So 174. One nine two 168 0 dot. I'll increase the font. Yeah, this is just a going through the scratch. It's not like, maybe let's say I'm trying to show my setup. That's it. So not complete details. Maybe tomorrow session I'll cover the proper details. Okay. So change settings.
Tomorrow, what is the topic? Containers.
Yeah, containers.
Docker
Today
or
it's except Docker. Like Docker anyway, it's a general thing, right? Like everyone knows about the Docker. So maybe we'll start about containers. So like what and all are there? And there is the internal concepts, right? Like the namespaces and C groups, right? So we can go through that. And we have CRI-O, we have Containerd, we have Docker, we have Rocket, I guess. So we'll just go through them, what are all each. So then ultimately we will start Docker as usual. So why we need to know about the containers? Because we are using Docker, but we don't know what and all is happening backside, right? So that would be useful at when you're learning Kubernetes things and all.
Okay.
Yeah, any questions there, man?
No, earlier sessions I was not there. Can I go through the recordings?
Yeah, sure. Yeah, so this is my lab, as in like I have my box, so I could show it. I'll show my camera. So yeah, this is my, if you see, right, this is my mini lab, as in I bought a mini PC. So this was imported from different place.
No, your
Okay,
video
it's
is a little blurring. Ritu.
okay. So this is my mini PC.
Mhm.
Okay, so this one I bought it imported, and this is my Raspberry Pi, where I have the dedicated Linux machines, these two. So where if I want to make any changes, okay. So let me take it back. Yeah, I think I showed it in earlier version, but like since I'm experimenting multiple things, so I needed a dedicated machine. Okay. So if you see on the screen share, right? So there are multiple processes are running. Okay. Let me increase it. So yeah, not happening this. Parents, window, terminal. Yeah, looks like. Yeah, so I hope it is visible better. See, this is when I did a Docker PS, right? So I'm just showing my what are all things I'm running there. So I have the image, I have bookmark, bookworm, and I have torrent file. We have Grafana, and node exporter. So I have the home. Okay. So it's like I can run any of these things locally. Okay. I can install the service and I can run locally, but I prefer to manage it in Docker. Okay. So why it is? Let's see. Yeah, and I can show you one example. See, this qubit torrent is there. So 6881. So 22, 60. Yeah, let me delete it. So this is a torrent service which I'm running from there, and I can access it here, okay, or any of my place. Okay. Or let's see if I can show you my Prometheus or Grafana. Okay. So Grafana is running in port 3030. This is new password. I'm doing a skip. And if I go to dashboards, yeah, so this is right now, this Grafana is about my internet speed. So let's say this is last 7 days speed details and all. Okay. So let's say last 30 days. Okay. So this is kind of application we use in production to monitor the things. But right now I'm just using to see my internet speeds and all if I have latency. Okay. So how did I set up? We will go through this later. Okay. But what exactly I'm trying to do here? Okay. So I'll see free-m and I have the top. Okay. So if you see top, right, basically, yeah, CPU. See, this is 0.3 CPU and all, and we have memory. Okay. So in memory, I have 16 GB RAM, but I used only 4 GB. Okay. I had 10 GB total, 10 GB RAM is available. Okay. So this we discussed in the Linux basics. Okay. So you have your properties. So one is your CPU cores. Okay. So I have my CPU cores as 8 cores. Yeah, sorry, my bad. 16 cores it is. Okay. Okay. This one it doesn't have a powerful GPU. Okay. And I have something called memory also. Memory is 16 GB. So now what's happening is I'm not utilizing complete of these resources. Okay. So whenever I'm trying to, whatever things I'm installing, right? So I'm not utilizing completely, but I might want to isolate it. Like sometimes I do want to use multiple versions. Okay. And also I do want to control how I'm assigning the things. Okay. So if I go here, so this my target is I do want to utilize all these resources, okay, using containers. Yeah, the containers as in you can see this, right? Yeah, these are all containers, right? So what you're trying to do, your goal is whatever your whole block is there, ship is there. Okay, you do want to put all the containers there. Okay, you do want to utilize complete data here. So you don't want to the load. Okay, you don't want to put the load everything on a ship itself. So you can pack into a container and you can put your container there. So that is what we are trying to do. We are trying to program through containers. So we have something called C groups and we have namespaces. So C groups provides you control over how much CPU you can run. Okay. So now I can assign this particular one, it can utilize only 1 GB. are one CPU. Okay. And network namespaces is, so this particular process don't want to mix up with this one. Okay. This particular process don't want to mix up with this one. So we do want something called isolation. And there would be one question. Yeah. So why we are going for containers is, that is one question. Okay. Let's say I wrote a program. Okay. Okay. So I wrote a program and I kept in one of the container. Okay. Let's say for some reason, how much time the program will take to load. Okay. So each program will have the steps, right? So you do want to install your libraries. Okay. And then you do want to copy the source code. Okay. And then you do want to start the file. Start the program. Okay. Let's say for some reason tomorrow this whole VM got disrupted. Okay. So immediately what you can do, you can spin up another VM, and while you all these containers, you can just bring it up here. That will be easy process because the container startup itself will take very less time. And if you're wondering why, like, see, when I'm starting a container, it might take hardly 1 to 5 seconds. Okay, max. So the question is, if I'm starting a VM, okay, so if I'm starting a VM, that will take somewhere like, okay, at least a minute or something. Okay, why the container is taking only 1 to 5 seconds? So that is because we are stripping of all the data. Okay, so if you take a OS and you have your hardware here, right? Yeah, I'll conclude in under 5 seconds. So you have your kernel and you have your hardware, you have your OS here. In OS, what will you do? You will have something called user space. You have your application, user application. Okay. You do have your regular things, and you have sudo, you have SSH. So all these programs are there. Okay. But to spin up a container, so what we'll do, we'll get rid of everything, all the operating system core things, right? So we'll get rid of everything. So like, for example, Ubuntu OS. Yeah, so if you see here, right, the Ubuntu OS size is 5.9 GB because it combines everything, whatever you need, whatever the users needed. Okay, so the drivers or whatever the data they need, everything will be here. Okay, the hardware drivers and all. But if I'm trying to run a Python container, so I just need one block of it. I don't need everything. Okay, the base OS things will be fine. Only the minimal things should be fine. So I'll write a minimal OS version. Okay, I don't need everything. I just need basic things. So this whole thing will make the container as very little as somewhere like 200 MB or something. So that's OS. So that is, we have multiple things. So something like Debian minimal or something like Alpine, which is very less size and all. So that's what we are trying to do. So we are trying to reduce the OS size, and we are trying to pack it as a container, and we are trying to run. So each thing, when it is running, right, the program will think like, hey, I am in a particular OS and all. I am in a particular new laptop or new computer. But for us, we know that, okay, we are trying to manage all these people, all these containers through at a single place. And how does it changes with the hardware, right? So this whole VMs we are running as a virtualization. Right? So virtualization and hypervisor. Yeah, now the next question is, how does your hardware supports it? Okay, how does your hardware allows the things to do something like this? Okay, so all these things they might come in the namespaces. So namespaces allows the we have network namespace, like it does need a complete different network. Okay, Yeah, it also need a different network. So, like everything, so we need a separate network, we need a separate storage, we need a separate CPU block or memory block. So that's about the containers in a nutshell. So tomorrow's session, I'll try to take in deep and we'll try to go through a demo and I'll try to cover everything, not only Docker. So I'll try to cover everything. And what will I do? I have some dummy app. Okay, let's assume I wrote some dummy application or something like that. Okay, so I do have. Yeah, maybe I can run this site itself. Okay. Yeah, this portfolio website, whatever is there. So what I can do, I can pack it and I can run it inside a container. Okay. Or a Python job, which can give out some particular details and all without storage. So I'll try to pack some things as a container and we can try to run them and see what happens. Okay. So mostly I'll try without including Docker, I'll try to cover other technologies. Once that is done, we can move forward, go through the Docker and how the things works. Okay. So I'll take a break here. We'll conclude the session here for today. So any questions, guys?